I live in Canada. I go to school there. I study biology and math and stirpetti, or stirpetti in inglese. Decided to have this lesson about solids of revolution, and I'm going to explain two different methods to calculate the volume of a given function when you rotate it around the x-axis or the y-axis. So, given a function f of x, we can calculate the volume generated by the revolution of this function around the x-axis by two methods. The first one is called the disk method. It's the one that you guys know. And to do so, we can create a little disk of radius f of x and depth dx. And if we slice the entire area from A to B into tiny disks, we can calculate the entire volume of this solid, like this. Close enough. If we can start off by calculating the volume of each one of those disks. Which is, okay, we first calculate the area, right? Which is pi r squared. And the radius of this disk is f of x. So the area is pi f of x squared. Now, if we need the volume, we're going to do the area times the width of the disk, so times dx. Now, as you guys know, if we take the limit of the sum of all of those volumes of those disks, we get the volume of the solid. So the volume will be the integral from A to B of A times dx, which is the integral from A to B of pi f of x squared, or pi A to B f of x squared dx. So this is the first method, but we can calculate this exact volume with a different method, which is called the cylindrical shell method. And to do so, I'm going to draw a different picture. So this is the same solid. No, never mind. Scusami l'interruzione, faccio prima lo stesso intorno a Y. Ok, allora.
La stessa aria.
Faccio prima questa. Più. So with the other method, instead of slicing the solid this way, perpendicular to this axis, we do it parallel to the axis of rotation. So we slice it this way. And we create those cylinders that rotate around the x-axis and cover the entire volume. I'm going to draw a different picture so it's more clear what I'm doing. If you have, let's say, this function f of x from a to b, that it's rotating this way, or let's say this way, you are doing this. You're slicing it this way if it's rotating like this, and you're summing up the volume of all of those little cylinders that go around, right? So in this case, we have, to calculate the volume of this cylinder, the formula of the area is 2 pi r, the radius times the height of the solid, of the cylinder. So the radius, we know that is this, right? Which, what would it be? What do you think it is? This. So we can write it as f of x, or if you think this way, what is this? Is f of x or y? You can write it as y, right? So the radius is y. And the height of the solid, which is this, what is that? This is the A, and this is B. How would you indicate this? Length. B minus it will be B minus whatever this is, right? This is y f of x. So you will think that it's B minus that. But there's a problem because the width of this little cylinder is dy. So the integral that you're going to take is going to be in terms of dy. So we need to express this in terms of y. So it's going to be b minus, let's say, we can call this, we can explicit this in terms of y. So you can write it as b minus g of y. Is that clear? Because you guys know that it's b minus that, but because it's dy, we need everything in terms of y. So now we can calculate the area of the cylinder, which is 2 pi y b minus g of y. And we do the same thing that we did before. We do volume is A times this as dy. And then we integrate from A to B. So volume is integral from, well, not from A to B, because it's the same thing as before. A and B are in terms of x. So we need to find, let's say, C and D, which are the limits in terms of y. And it's just the value of this function at point A and B. B and A. So let's call it C and D, 2 pi y b minus g of y. We can take the 2 pi out, so it's 2 pi c d y dy. When we do it with a real function, it's going to be easier to see, like, because this is going to be a constant, which you can take out of the integral, and then just
Okay.
right? Yes. So now we are going to take the same function again. And we're going to rotate it around the y-axis. We're going to use both methods again, and you guys are going to see that one of them, it's clearly easier to use around the y-axis, and the other one is easier to use around the x-axis. So the first one that we did was the disk method, and I'm going to redo it again. So if you rotate this function around y, you obtain something like this, right? Where this is A and this is B again. Now, if we do the disk method, we slice it perpendicular to the axis of rotation, so this way, like so. So we take all of those little disks, we sum them up in the limit from here to here, which we're going to see what they are, and we find the volume of the entire solid. So we need the volume of one of the little disks, and as we did before, we need the area, which is pi r squared. What is the radius of this little disk? What is this?
G of y. G of y.
So we are going to need to, if this is y is equal to f of x, we need to explicit. This is how we write it in Canada. I don't know how you write it. But we do it like this. You write it in terms of g of y, so r is g of y, and so this is pi g of y squared. Right? Now to find the volume, we need to multiply the area by this little, the depth of the disk, which is it going to be in terms of x or y?
Y.
So it's going to be dy. So now if we integrate, the volume is pi g of y squared dy from where to where? From C to D, because everything is in terms of y. And this is the same formula as before, but in terms of y. So now we do the same thing with the other method. So instead of going this way, we go this way, right? We go parallel to the axis of rotation. So we do something like this.
More or less.
Non ce li fate vedere più. Okay, so again, we need the volume of one of the cylinders, which is, we need the area, it's 2 pi r times h. Now, if we need to find r, this is r, and from here to here, it's the ith of the function, right? So, what is r in this case?
A meno C.
R.
Meno C.
Just this
A minus C.
is in dx, so you need everything in terms of
Dx.
x, right? So from here to any point is x. And what is this value? It's easier than what you think.
Epsilon.
It's if it's hard to see here, but if you imagine this here, you can see that it's f of x, right? So the volume is two pi x f of x times dx. Now, if we integrate the entire thing, we get, this is of one little cylinder. Here we get 2 pi A B. Okay?
Yes.
Okay, now, when you, independently of which method you use, when you rotate around the y-axis, you need to be careful of what you're rotating. Because if they give you a function like this, you can rotate the function from A to B, or the area under the function from A to B. And you get two different things, because if you rotate the function, you get this solid. But if you rotate this, you get this solid with the hole in the middle. Okay, and both methods work for both of them, because you can do it, you can do this or this for this one, but you can do the same when you rotate the function, right? Okay. Thank you. So now what I want to do is take this function and rotate it 4 times. 2 times around the y-axis and 2 times around the x-axis. I don't know which is it for. And see that with both methods you get the same result, right? So if we take that function and the area from 0 to 4, and we rotate it around the x-axis with the disk method, and this is the formula, we get volume by f of x is square root of x squared dx from 0 to 4. And if you guys solve this, you get, well, I'll do it, whatever. Now, if we do the same thing, the same volume, slice it the other way, we'll get I'm going to write the general formula like this. And in our case, we have the radius that is this, right? Because we're rotating this way. So this is the radius, and this is h. And we need everything in terms of x. So the radius is, what is this? We need everything in terms of y, sorry.
dy, no?
dy. The radius is y, and this distance is 4 minus g of y. And in our case, g of y. Y squared. So the integral is 2 pi from, what is this limit? We need everything in terms of y, right? So we're going from here to here. What is that point?
2.
So from 0 to 2 of y, 4 minus y squared dy, and this is gives you the same result. Tutti e quattro. Okay? Now we're going to rotate this around the y-axis. And if we do it with this method, we go like so. And you can start to see that doing this is it's more complicated than doing this, because here you have two different radius to calculate, right? You have to take the volume of the entire cylinder and then subtract this. Whereas if you slice it this way, you just take one volume and you're done, right? But if we do this, anyway, we get and this one would be in terms of y, so we need everything in terms of y, right? In this first case. So it's from 0 to 2 of the radius of the big cylinder, so of 4 squared times dy minus the volume of the inside one, right? And the radius of the inside one is that one, which is, this one is the value of the function, but we need it in terms of y. So it's y squared, right? So that will be the integral of y squared squared dy, and this is 32 pi minus 5 the integral of this, and it gives you 32 pi minus 32 pi over 5, 128 pi over 5. Now, if we do it this way, we will have, the formula is 2 pi r h dx in this case, and R is this. And H is that. So R is X. H is f of x. So this is the integral from 0 to 4 of x square root of x dx. It's easier because you don't have to take out the hole in the middle, because you're just doing this. And basically every time you use the disk method, to me it's confusing, because if you rotate around one axis, you're in terms of the other variable. No, never mind, the shell method. It's confusing in the other case, because you're rotating this way, but everything is in terms of x. So this is really the only case where it's easier. Ah, dobbiamo parlare. Io non ce l'ho però. Non ce l'ho. Non capisco il disco.
E poi c'è cosa tutto il cilindro da questo, però.
Quindi fai questo. Io lo faccio subito, io scrivo questo. E dico poi come lo fareste quello?
Questo qua. Questa è la funzione. Torna alla settimana. Non posso più usare il spettro. Perché non è per dirla, c'è queste crescente di non piccolo che si spezzano. Che sarà non già fatto.
Scusa,
sono un po' di male a pensare.
ho capito.
La cosa questa è
Infatti stiamo sempre attenti. Cosa hai fatto?
una funzione che non calcola è possibile avere rischi con la y.
Si ammalato.
Questa è 3 punti.
if you guys have seen this function, because it is and they're asking to find the volume generated by this, the area under this function around the y-axis. Right, now if you cannot do this volume with the disk method, because if you cut the function, the area, this way, you need whatever. You need to find
Uy.
the radius, which will be g of y. And but if you use the other method, you don't have to do that, because you are going you go this way, and all you need is H and R. Well, you have to take this part of the function out, but it's easier to get. So 2 pi from
0.
The formula is what is R and what is H? H is and R is
X.
No? Okay. Don't you think she's fantastic? Thank you very much.